All right, folks. Today we're going to find the range of quadratic tables. I'll show you how to do that. Quick little notes, and you got a quick little assignment. Only 3 questions, multiple choice. That's pretty easy, right? You got to know this little skill on how to look at a table and find the range. I'll show you today, but a couple things. These assignments are due: the aware, quadratic key features, and quadratic domain and range. Make sure you turn those in. They look like these. I need to put the one from yesterday right here, but remember, grades are all due by next Friday, the end of the grading period, right before spring break. Woo. Quiz is supposed to be tomorrow. We'll see, but that's the plan. Don't forget, tomorrow after school, free snacks. M201, right here, free snacks. You should come. Now, looking at this graph, what's the equation of the axis of symmetry? The axis of symmetry has an x in it. What do we always have to write for the axis of symmetry? X. There's an x in axis, and the equation is always going to have x equals. Now, do you know how to draw the axis of symmetry? I need more people looking up here. Look. Everybody, right here. Axis of symmetry cuts it in half. So, like, if you were to draw a parabola, this, shape right here, and you cut it straight in half, that would be the axis of symmetry, right? And my line is not very straight, but you see that it goes through what x value? What x value is it going through? 1.5. So your axis of symmetry is always x equals the x value it goes through is 1.5. Okay. Quick little notes today, so make sure you have that warm-up done. Here's your, again, these notes are going to be short and sweet. Alrighty, short and sweet. Okay. So let me make sure everyone's got this first. Okay, here we go. Make sure you write this down. For the first top part of your notes, that domain is all possible x values, range is all possible y values, vertex is the lowest or the highest center point of the parabola that looks like a U. It's either going to look like a U, like this, or it's going to look like a hill, like this, but the vertex is where it changes directions. Changes direction. Okay. Okay, I'll give you a couple more seconds. Write this down, please. Everybody, we're writing this down. If you're not writing, let's write this down. That might be one right there. Shelf. Okay, everyone get this down quickly because we gotta do this. Turn it back there. Okie dokie. Ready? Let's talk about finding the range. There. We got to move on. I got to change it. So sorry. All right, here we go. Oh man. Here we go. So right here, the domain of a given table. Okay, so check this out. Is everyone looking up here? This is new stuff. It's going to be short and sweet, but you got to look. Okay. Now, domain. If you remember from our last notes, it goes forever to the left, forever to the right. The domain is always going to be all real numbers, okay? All real numbers, for sure. Okay. So I see a table. I know the domain's always going to be all real numbers. So let's go ahead and look at this down here. First, we locate the what? First thing we're going to locate is the y values, okay? So y values. I'll put a little star right next to it. There they are. There's the y values on the table. That's my range, okay? All right. We know the domain, like we already said, is all real numbers, okay? Did we locate the y values? Yes, we did. Okay, step 2, find the vertex. This is where the y values start repeating on both sides. Now, all you're going to do is look at these y values and see where does it repeat on both sides. So what are my y values here? I have 7, 4, 3, 4, 7. Do you see how there's some symmetry there, some repeating numbers? But where does it stop repeating? Where's the center number? 3, right? You got 7 and 7 repeating, 4 and 4 repeating. So 3 is like the center. We call it the vertex. So even though you can't see it on a graph, you can kind of see it in the numbers on a table, wherever they're, kind of symmetrical, wherever they meet, that's the vertex. Put a box around this. This is the vertex, okay? So fill that in for number 2 on the right side. What is the vertex? It's going to be 0, 3. I found it. That's where it's not repeating on each side, or where it is repeating on the left and the right. So let's go ahead and write that in right here. It repeats to the left. It repeats to the right. All right, now step 3, determine if your y values are increasing or decreasing. Okay, now what is increasing? Well, that's going to be the symbol greater than or equal. And decreasing would be less than or equal to. So if we have increasing numbers, you would put the increasing symbol greater than or equal. If you see decreasing numbers, that would be the decreasing one, less than or equal. There you go. All right. So how do you know what the vertex is? Repeats left and right from there, okay? So again, you get repeating numbers from the left and the right. So are the y values increasing or decreasing? Now, lock in here, check it out. It starts at the vertex of 3. As you go left and right, it goes to 4. As you go left and right, it goes to 7. So as it goes from 3 to 4 to 7, is that increasing or decreasing? Does everyone know 3, 4, 7 is increasing? So increasing means greater than. So for the bottom, my final, answer, what would my range be? Well, if it's increasing, right? Let's go ahead and put that for number 3 here. I see it increasing. That means I have to use a greater than or equal to sign. I'm going to put y for my range greater than or equal to my vertex y value is 3. Does everyone see that 3 is where I started in the middle? It increased from there, left and right. So it has to be greater than or equal to that number. And it's a range, so it's a y value. Y greater than or equal to 3. Cool? That's how you can do it just by looking at it. So technically, I could probably just give you this now, and you can do 3 problems just by looking at them and tell whether it's increasing or decreasing, and do it from this. But for funsies, flip it over. I'm going to show you how you could do it in Desmos. Okay, obviously a table, you can't see it. I mean, there's numbers, but you can't see it graphically. So you could use Desmos to graph, right? So, does everyone have this written down? Okay, flip it over to the back. On the back, fill in this first little piece right here. We know that the domain is always going to be all real numbers still, right? Now, you don't have to do Desmos. I'm going to do it for you right here. But I want y'all to see over here. You see this table? Okay, I already put it in. I hit the plus sign on Desmos. I typed in all my X and my Y values, okay? And you can kind of see that the repeating 5s and 8s mean 9 is my vertex, but you can also just see it on here, right? The parabola is curving up and going down, right? If I were to take a look at this, it would look like, if I were trying to like sketch it, come on, man. Bro, I do not like this. It's not working for me. Okay. Well, I tried. So again, you can see the parabola. You can see the tippy top right here is 0.759. So for our domain, you can put all real numbers. Okay. Do you see the parabola shape? Again, if you follow those points, yes, we see the parabola shape. The vertex at the top is 0.75, comma 9. Now you tell me, from that vertex, is it going up or down? From that maximum vertex, it's going down, down, down. So the y value of the vertex is 9. Since it's going down like a frown, it is decreasing. So we're going to have to use the decreasing inequality, which is a less than or equal to sign. Okay. So let me zoom in on this so you can see it. So that means y is going to be, as it goes down, less than or equal to the y value of the vertex, which is 9. Okay. Now, I want you to try these bottom two. You can do it in Desmos, or you could just do it by taking a look at it, seeing where it changes direction, starts increasing to decreasing or decreasing to increasing, and then write your domain and range. Remember, domain is always all the numbers, range is depending on the vertex. Now, I'm handing you the assignment already. We're going to go over these two examples together here in a minute, but it's a pretty quick a pretty quick assignment to do, which you will probably still have time to finish yesterday's assignment, front and back. But again, I want you to knock out this quick little 3-question assignment first. So I'm going to give you like literally a minute. Try these two. Try these two. We're going to go over it. Then you're going to do that assignment I just gave you, and then finish yesterday's work. Okay? let's do it. So this first one, I think everyone should know by now, the domain of an unrestricted quadratic parabola is all real numbers. And then the range, now where does it change? Where does it stop repeating? So I got -1, -1, -4, -4, and then I have -5. That's going to be my vertex. And what do I care about? The y value, -5. So here's how you do range. You write the y value, or so you write y. The y value is -5. But is it going up or down? Please think carefully about this. If it starts at -5 and then goes to -4 and then goes to -1, is it increasing or decreasing? Increasing. So if you go from -5 to -1, like think about it on a vertical number line, okay? -5 is lower than -1, right? A smaller negative is a bigger number. I know it's weird to think about, okay? So from -5 up to -4, up to -1, the next numbers are going to be positive. You can see how it's getting bigger and bigger. So this should be a greater than sign. It is going up on each side. So greater than or equal to. I know this one's tricky because -5 to -1 seems like it's going down. It's not, okay? That's why graphing it on Desmos might help you, okay? Last one. I see repeating -3. Oh, but first of all, don't we know the domain is all numbers because there's no restrictions. But then -3, -3, 0, 0, 1. Here's my vertex where the repeating stops. My y value is 1. y1. Is it increasing or decreasing from 1 when it goes to 0 and then -3? 1 to 0 to -3 is going down. Down is less than or equal to, okay? Make sure you have this written down. No pun intended. Down, down. And do today's assignment. 3 questions, multiple choice, shouldn't take you too long. But then make sure you finish any of the last 3 assignments from yesterday and earlier in the week, last week, okay? Let you work.